Welcome. There are various methods that is used in solving a simultaneous equation. You might prefer the elimination. You might also prefer the substitution using the Cramer's rule, or we can also use the matrix approach. So in this episode, we want to concentrate on how we can use matrix in order to solve a simultaneous equation. So first thing first, we can translate all these to become a single matrix. All right, so how do we do that expression? We can see that we are picking the coefficient. So this will be 2, this will be minus 3, the coefficient will be 1, minus 1, and that will be multiplied by x, y, and that will be equals to the 4 and 3. So you can see we have 2 by 2 matrix, 2 by 1, and another 2 by 1. So these are the matrices we are having. So what we can do it mentally by dividing this both sides to become the inverse. Or we just say let A equals to the matrix 2, 1, minus 3, minus 1. Then we let x also equals to xy. Then we let b equals to 4, 3 as the various matrices. So that gives us A, which is the matrix, times the x, which is this. So be equals to the final part, which is going to be b. So we can write this, let's just say by illustration. We can write this. And you can see that we are paying attention to the x. We know this as a matrix, these two. So what do? Per equation, we divide by the a. And if we divide by a, it becomes b minus divided by a. With under indices, we can also say b times a prime, which is the inverse. So this inverse is in a matrix. The inverse of this matrix times the b will give us the value of x. So directly, we are only going to imply that our x will be equals to the inverse of a times what? B, the inverse. So how do we find the inverse? We have to find the inverse using matrix. So we know inverse of a is going to be 1 over the determinant times the adjoint of the matrix A. So we are going to put them in directly. How do we find the determinant? Let me just increase here. Determinant of A. So we are going to have the determinant of A equals to, we multiply leading diagonal 2 times negative 1. That will be negative 2 minus the other diagonal 3 times negative 3 times 1 will be negative 3. This becomes plus. So your answer is going to be 1. That is minus 2 plus 3 will give you 1. Then the adjoint of A. So adjoint of A is just, okay, let me just write this directly. 1 divided by 1 times the adjoint of this. What is the adjoint? We are going to swap the position of the leading diagonal. Minus 1 comes first, then 2 goes down. Then we maintain this by negate them. Add negative to the first one, add negative to the second one, then we have that. So negative times this will give you positive. Negative times this will give you negative. And you can see the 1 will not have any effect. So the image, the inverse is just minus 1, 3, 2. That is the value we are getting. Then the value of x will now be equals to the multiplication of the, what is it? The inverse. Minus 1, 3, 2 times b. And the b is what? 4 and 3. How do we multiply matrices? We are going to multiply it by saying that 4 times negative 1, negative 4, plus 3 times 3, 9. That gives us the first entry. This times this plus this times this. Then the second entry, 4 times this will still be negative 4 plus 2 times this. That will be what? 6, right? So in this case, if you compute this, we have 5. If you compute this, we have 2. Meaning x equals to 5 and y equals what? 2. We are solving for x and y. So the value of x and y in this equation is 5 and 2 if we follow the matrix approach. I believe you've grabbed the concept. You can play the video back again and capture all the steps that you need. Thanks for watching. Like, share, and comment. Bye-bye.